no, it's great. Looking forward to finishing it.
Yep. I'll work on it a little bit today to, and now, yeah.
Okay. Do we know if
Philip, you're presenting today?
I'm presenting, yeah.
Okay, cool.
The others still traveling? Do we know?
I like your glasses.
Oh, the new ones?
Really? It's a great fit.
The emergency glasses, because I threw my old pair in the harbor just to South Africa.
In South Africa, not on your boat. Here. Okay. This is really nice. I like it.
Went to the optician, was like, I need glasses, but I'm leaving in a few hours.
Well,
this was the only set they had.
That's great, I think.
Thank you. Okay, Team Bordeaux is stuck at the airport. That's a shame. Okay. In that case, it's just...
That's okay, yeah. I can start. Yeah.
So Philip, if you want to share your screen.
Yes, just a moment. Perfect. Can you see my screen?
Perfect, yes.
Just a moment. Yeah.
So today we're going to talk about developmental dyscalculia. Exciting.
Yes. Perfect. So yeah, hi everybody. For today, I prepared a paper about developmental dyscalculia because some weeks ago we had a presentation about dyslexia, and I thought it would be interesting also present developmental dyscalculia because both disorders are have pretty high comorbidity, and maybe this paper can spark some interesting discussion in the end. So for today's Neuroccino, I prepared the paper titled The Two-Network Framework of Number Processing, a step towards a better understanding of the neural origins of developmental dyscalculia. And developmental dyscalculia, or sometimes I'll just say DD, because it's developmental dyscalculia is just a mouthful. So DD is a specific learning disorder that persists over lifetime, and it affects the processing of numerical information. So people with dyscalculia will typically suffer from difficulties in reading time from analog clock phase, for example, or from poor memory for number-related facts and dates, and they will show an inappropriate money-related behavior as well. So developmental dyscalculia has an enormous impact on both personal and professional aspects of life, and its neural origins and cognitive processes are not yet well understood, and most theories that had been put forward are mainly mono-causal, focusing on gray matter deficits. But in this article, the authors proposed a two-network framework. They also specify the white matter tracts that are affected in developmental dyscalculia, and the two-network framework, they imply on one hand magnitude processing, and on the other hand arithmetic fact retrieval. By arithmetic fact retrieval, I mean those are simple calculations, like simple additions or simple subtractions or multiplication tables that we have stored in our memory, because these problems are overlearned. So whenever I speak about arithmetic fact retrieval, we don't really have to calculate anything. We just need to recall the result from memory. Like if I give you an example of 6 times 6, you would immediately know that the result is 36. You don't really calculate anything there. And the previous, this is actually an updated version of the two-network framework that I will be presenting. And the previous version was based on the probabilistic fiber tracking, but now the authors also integrate new findings based on acute stroke patients and disconnectome mapping. And in this paper, they also develop a classification schema of different phenomenological subtypes of developmental dyscalculia. But the article itself, it starts by commenting on a very influential model of number processing, which is the triple code model by Dehany and Cohen. In this model, the author specified different codes for different number processes. Concretely, 3 codes. The first one would be an analog, abstract, and automatic code for magnitude processing, which would be located bilaterally in the IPS. The other code would be a verbal code where the arithmetic facts would be stored, and this would be located in language areas and also in the angular gyrus. This is an important area for the arithmetic effect network. And the third code would be the visual code that would be mainly engaged when processing Arabic digits and number words. And in 2016, Klein, the first author of this paper, or the present paper, extended this triple code model by white matter fibers, by the dorsal and ventral tracts, and it resulted in a 2-network framework, because they observed that there are actually 2 separate networks, one for the magnitude processing, the other for arithmetic fact retrieval. But they also suppose that there is some minimal amount of processing whenever we are engaged in the arithmetic fact retrieval. We would also engage in some minimal magnitude processing, and vice versa, the other way around. If I illustrate this with a simple example, if we have to calculate this rather complicated addition problem, 372 plus 491, it can be broken down in more simple problems, such as when we would add the 2 plus 1. We don't really calculate anything here. We immediately know the result from long-term memory. So some minimal processing is always present in both networks. So this the 2-network framework was based on healthy participants, and the authors also want to know whether this network is whether some of the assumptions can be validated or extended by data from a recent study. That's where they studied acute stroke patients using the disconnectome mapping, and I'll just briefly go over some of the assumptions that were validated by this sample of cognitively impaired participants. So first, in this study by Smechny and colleagues, they confirmed that there are 2 dissociable networks, because lesion disconnections in the left hemisphere, it comprise the connectivity of the angular gyrus, the superior middle temporal gyrus, and supramarginal gyrus, which is actually the hub for the arithmetic retrieval network, and it compromised the multiplication factor retrieval, while addition and subtraction was preserved. And this occurred only when the left hemisphere was affected. So this is also consistent with the fact that the arithmetic factor retrieval is left lateralized. And I just mentioned that when the arithmetic fact retrieval was impaired, the multiplication was spared, while solving additions and subtractions was preserved. But I don't want to give you the false impression that one network is engaged with for specific types of operation. It rather depends on the difficulty of concrete problems. And this was also confirmed in a recent TMS study, inhibitory TMS over the angular gyrus, which was detrimental for both simple multiplication, but also for simple subtraction, but more difficult multiplication and more difficult subtraction problems were not affected. So this is not a, so it is rather the amount of difficulty rather than different types of operation that are affected. And I just told that They also confirmed that the arithmetic network is left lateralized because also damage to right hemisphere did not affect multiplication tables. And this study also showed that this disconnectome study also showed that the arithmetic factor retrieval network is more widespread. And they also extended it by adding more tracts like the left target fasciculus, the temporal pontine tract, and U fibers between angular gyrus and superior middle temporal gyrus. And here are the two networks represented visually. This is the magnitude processing network, which is represented bilaterally. The central region would be the IPS, while the arithmetic factor retrieval network is left lateralized. Here in the pink rectangle, I highlighted the hub, the central regions for this network. And there are also some regions that are shared between both networks. This would be the visual number form area, which is where the visual code is stored, important for processing Arabic digits, and also the IPS. The IPS is shared between both networks. It is not central for the arithmetic factor retrieval, and the authors hypothesized that this network is engaged when we have to switch to, when we are engaged in arithmetic factor retrieval, but we need to switch to magnitude processing. And we also see that there is hippocampus in green. This is an important structure, of course, for encoding information, but once these simple additions, subtractions, and multiplication tables are learned and overlearned, the activity in hippocampus, it's not crucial for this network. And also in this panel, in the panel B, the authors simply put it in visual fashion, the stable component in each network that is always present, always active. So the networks are separate, but always in interaction. And I just commented on this. And the basic assumptions of the TNF, the two network framework, are that the magnitude network is represented bilaterally, while lesions to the right hemisphere should not lead to deficits in arithmetic factor retrieval, and it should not be possible to fully compensate for deficit in one network with the engagement of the other network. And in the second half of the article, the authors speak about the implications for developmental dyscalculia and how this model can accommodate the findings on developmental dyscalculia. So previous models, they considered only one frontoparietal regions, which is not a good place to start because developmental dyscalculia is very heterogeneous. And also previously it has been theorized that that there must be some that the main needs to be dysfunctional for dyslexia, for dyscalculia to take place. And the authors also highlight that the previous model were mono-causal, while the TNF suggests 4 major subtypes of developmental dyscalculia, which can either stem from impairment from the factor retrieval network, or from the magnitude retrieval network, or from impairment in both networks, or at the impairment at the interaction with each other. I'll just go quickly over the various hypotheses that were put forward to explain the arithmetic factor dyscalculia, which would stem from impairment within the arithmetic factor network. And this dyscalculia would show itself as a failure to establish the stable representations of arithmetic facts like multiplication tables. This is also the most common impairment observed in developmental dyscalculia. And although despite the agreement of this principal impairment, there are various hypotheses that have been put forward. The first one is called the hypersensitivity to interference hypothesis, which stems from the fact that different operations have feature overlap. So in these two calculations, in these two multiplications, both overlap in the number 3 and also number 2. So there would be a proactive interference, mainly when learning from previously learned problems to future problems. And this theory says that children that would be hypersensitive to this interference would not establish stable representations of this multiplication tables, possibly because of a deficit in a top-down cognitive control. So the TNF network suggests that there should be a structural or functional impairment in the long association connections between frontal and prefrontal cortex and the ankylogyrus, important for arithmetic fact retrieval, the hippocampus, or the visual number form area. In order for this theory to hold true. Well, there are actually like 3 theories to explain this arithmetic fact dyscalculia. They can also be complementary, and the TNF network always, the authors always mention the structures that should be impaired in order for these theories to take place. The other hypothesis is the access deficit hypothesis, which states that children with developmental dyscalculia, the problems are not related to problems with numerosity, but problems in accessing the magnitude information from symbols. And this theory received a lot of attention in the literature, but the TNF network, it rejects basically all of them and proposes that there should be a deficit in the connectivity of the left visual number form area, which is engaged when we process Arabic digits. And problem in this area would lead to this failure of association between numerical symbols and their numerical magnitude. And they also have hypothesized, because this area is in a close vicinity to the visual word form area in the fusiform gyrus, and it is expected that there should be a high comorbidity between dyscalculia and dyslexia in this type of dyscalculia. And there's a third theory that supposes that there is a long-term memory deficit, which would stem from deficient hippocampus. But this probably is not. But problems with hippocampus in general would lead to generalized learning disorders. So the TNF theory rather supposes that there should be problem in the hub that I showed you earlier, rather than in the hippocampus itself, to observe a selective impairment of arithmetic fact retrieval. Then I'll quickly go over the impairments in the magnitude network, the other network, which is also embedded within superordinate frontoparietal task positive network. So this impairment in this network can lead to both number-specific subtypes or number-unspecific subtypes. I'll just quickly go over the number-specific subtypes. And of course, problems with the magnitude network would lead to, normally it's assumed that there's a problem with the IPS. And if the IPS is hindered, then this would lead to general dyscalculia, because it would also affect the establishment of arithmetic effects. An ability, because in IPS it hosts the approximate number system, and we can represent quantities, and thanks to this system. So this would also lead to failure in consolidation and acquisition of basic arithmetic skills as well. And most theories proposed that the IPS should be deficient, but according to the TNF theory, we should observe the general dyscalculia only under the premise that the IPS is affected bilaterally, and also its dorsal connections, if their dorsal connections are affected, because the number representation is in the end distributed and not only localized within the IPS. And curiously, there is also developmental dyscalculia subtype where the numericity processing is affected, but children with this subtype don't have difficulties in basic arithmetic. And the authors of the TNF theory proposed that the visual dorsal processing pathway connecting the visual occipital cortex with the IPS should be affected in this case. And I'll just show you quickly what connection they mean. It would be this connection. Okay. Just go back. And I won't comment on the number on specific subtypes, but just to quickly show the third category of developmental dyscalculia subtype that the authors mentioned. It would stem from the impairment in both networks, namely from the left visual number form area, which would affect both calculations and fact retrieval. And whenever this would take place, children or even adults would be prone to deficits in processing other visual, other written symbols. This would lead to high comorbidities with dyslexia as well. And when it comes to the impairment in the network interaction, this would be at the interconnection between angular gyrus and the IPS via thalamus or via U fibers. And the authors hypothesized that if the U fibers would be impaired, then possible comorbidities, we should see possible comorbidities such as problems in associative learning and memory-guided behavior in general. And if the connections with thalamus would be impaired, we should also see further problems in word reading, comprehension, or reorienting attention to relevant information. And actually, so TNF proposes 4 different subtypes of developmental dyscalculia, and also highlights which connections or which structures should be impaired. And to test this framework, it is the authors comment that it is rather complicated, mainly because we should have like very precise tasks that tap either to the arithmetic retrieval network or magnitude network, but children who suffer from developmental dyscalculia can even solve problems that you would think would be solved by memory retrieval. They can use some compensatory strategies like counting with fingers. So the tasks to test this hypothesis should be very precise. And also in the past studies, many studies did not analyze the functional or structural connectivity, which is crucial for the TNF network. And most studies were focused on the IPS, but it is not a good candidate structure to formulate clear-cut hypothesis because it is involved. IPS is involved in both networks. So the study or the network remains speculative for the moment because we have scarce data, and this network is also was developed based on data from educated adults with mature neural circuits and arithmetic expertise. So only the future will tell how well this explains developmental dyscalculia. But to end on a positive note, the TNF network represents a shift from isolated dysfunctional areas, from a pure localizationist approach to complex interaction in the context of distributed but connected function systems. Now, I just want to leave a couple of minutes for questions.
Lovely. Thank you for presenting, Philip. As far as I know, Eduardo has a couple of questions for you.
Perfect.
Yes. As per being late, I have to ask question.
Mm.
Thank you for the presentation. Lovely to have a theoretical paper. Such an interesting topic. And yeah, so a bunch of questions actually. One is so from what I got, they based this to network theory, to network framework on studies involving mostly basic or simple arithmetic operations as sort of indicators of mathematical abilities. I was wondering whether you think, or whether they mention if this could be a factor that might be mediated largely or substantially by verbal abilities, because I don't know, if I think about other kinds of mathematics, such as geometry, I would think that that has a more like a sort of visual spatial component compared to basic arithmetics or stuff like that. So if they mention that, or if you have any general thought on that.
Yeah, verbal abilities are crucial. Thank you for the question. It's a great question. Verbal abilities are of course crucial. But you had difficult problems. They always engage in this IPS, the intraparietal sulcus, and we always need to be processing magnitudes when difficult problems are, and when we are presented with difficult problems. So
because oh, sorry.
Yeah. Continue, Eduardo, if you.
No, yes, sorry, because another of my question was related to the IPS, because we know it's crucial for mathematics or mathematical abilities to emerge and to keep going. And it's usually the left intraparietal sulcus that is the focus of attention, which is the left hemisphere, so the same as language, generally speaking. But I also find interesting that it's the intraparietal sulcus, which is an homologous region of the traditionally right hemispheric visual spatial network. So there was also like substantial bilateral like interhemispheric connections. So yeah.
Yeah, I would just comment that verbal abilities are of course very important. It's more important for the arithmetic fact retrieval network. And yeah, I would need to revise the literature to give you better.
No, yeah, the other way
better answer.
It's a gigantic task. But yeah, thank you. I've no, Muge can go, and then if there's time, I have a last question.
Hi, thanks, Philip. So I have a naive question. So for example, if you ask, is 5 bigger than 3, is this a magnitude processing or is this fact retrieval? I'm not quite,
yeah, this would be
knowledgeable about. No, I don't have a lot of knowledge about this.
This would be especially resolved by the magnitude retrieval, because you are asking about.
So it's a fact retrieval in there.
No, this will be the magnitude. magnitude.
So it's magnitude processing.
Yeah, magnitude processing. It always depends on how you present the
Question.
the problems. If you present it with Arabic digits, it would also recruit this visual number form area, a part of from the magnitude network. And if you present, for example, like dots, then it would engage the magnitude network. You don't have to the arithmetic facts. Those are like overlearned problems. Like, for example, 6 times 6, 7 times 7, 4 times 2, or 3 times 3 plus 5, where we don't really calculate anything, but we just retrieve the information basically from memory, because we've been learning these problems. We had learned these problems in childhood, basically, and we're exposed to this for a long time.
So because for me, like, it's really interesting that these things overlap a lot, right? It's hard to dissociate them from each other, and then the existence of two separate networks for processing these largely overlapping problems is a bit interesting. But in this case, what I understand is it's just how you present numerals or numbers affects which network will be engaged. So it's right.
In the end, it is interplay between both networks, and even the authors have this in mind, and they always hypothesize that there should be this stable component from one network.
And like IPS is the stable component in this case, you would say?
In this case, they have hypothesized that the right IPS would relay information from the magnitude network to the fact retrieval network. So IPS would be the area that we could identify as the stable component.
Yeah. And I had another naive question. So this dyscalculia in children, like how does it correlate with, I don't know, like IQ scores and stuff like that?
So developmental dyscalculia is a specific learning disorder. I'm not sure about the correlation with IQ, but it is like independent disorder that affects specifically numerical processing.
Like, for example,
I'm not really sure if it correlates.
Yeah, it's like I'm just thinking, like, if you show a kid, like, is this tree is bigger than this tree, or like it's also kind of magnitude processing, right? Or does it always have to be like numbers that
either numerical, either magnitudes or this arithmetic facts. But we have seen that it is quite heterogeneous as well. So you can have affected either one network or the other, or both, or the relationship between both. But numerical information of some sort would be affected.
Okay. Yeah, thank you. It's very interesting.
Welcome.
Thank you.
Eduardo, you had one more question. If it's a quick one, you can go.
I'll try to make it quick. It might be related also partially to what Muge just said, and I was wondering whether they mentioned anything about the evolution of this network, because we do know that a lot of animals have sort of magnitude processing abilities down to fishes. So that seems something that has been preserved a lot across evolution, and the emergence of highly precise arithmetical abilities is fairly specific to humans. So I wondered whether it makes sense that there is a tighter link with the linguistic network. Maybe they talk about the acute physical in some regions that are shared with the language network. So
they don't really speak about the evolution of both networks. They actually say that it is not a model of developmental model. It's also based on data from adults. But it is interesting to see that also animals have some approximate number system that has been studied in bees or in insects, and also in little chicken. So that's from commenting on that. But yeah, it's not neurodevelopmental model. And the authors also highlight this fact as a limitation of this two-network framework. So, yeah.
Okay, interesting. Thank you.
Thank you, Philip, for presenting. Thanks, Eduardo and Miguel, for your questions. That's all the time we have today. So great to see you all again. Have an exciting week in science. And I see you next Monday for the next Neuroccino. Bye.
Bye-bye.